What's up, everybody? Welcome to Unzapped. I am making this video as the final conclusion to my audio analysis. I've had quite a bit of time now to really kind of put this together, and I'm really going to break this down stupid style, because there are people that are doing very complicated math to figure out, based on a bunch of different mics, where the shot could come from and all that. And it's very complicated, and it's riddled with assumptions, meaning if you want to measure where a reflection is, you have to kind of determine where possibly that reflection could have came from based on the mic's position. So you have to do a lot of guessing in order to get that math to work. And that's where I reject those results. I just feel like it's overcomplicating it. And, you might disagree, and that's okay. I want to speak to credentials, because I've had conversations with people that have asked me, well, what is your background? What is your credential? Da-da-da-da-da. And I don't know how else to put it, but I am not an audio expert. I was a DJ for several years, 20-something years probably. I'm a tinkerer. I'm an inventor. I have been in IT for over 30 years, and I now hold a director level position with 30 some odd people that report into my organization. And basically, I'm a problem solver. This is what I do every single day. I look at the tools that are around me, and I look at how I can solve problems. And I have a lot of big problems in some of the IT stuff that I'm doing right now. So that's my credential. Now, does it fit an audio analysis of a shooting? I don't know. Does it have to? I've seen lots of people with credentials on their wall think that Charlie Kirk may have gotten electrocuted. I've seen people with credentials that think that a 30-06 bullet entered the neck and got stopped by the skin in the back of his neck. So I don't know if credentials really make a difference here. Hopefully, when I get through this video, you'll understand that this is more common sense than anything, and just looking at some basic information and coming to a conclusion. So I'm going to start with that. And also, I want to preface this with saying, when I decided to do this, when I decided to get Grandpappy's 30-06 and set up a target at 142 yards downrange and set up a whole bunch of microphones, I'm actually set up like 7 or 8 microphones, because I was going to do that real complicated analysis to see if I could validate and pinpoint where the shot came from. Even though I knew it, I just wanted to validate it. And I'm like, I don't really need to do any of that, because I decided to start with something very simple. And I'm going to show you that right now. So we've all seen lightning and counted 1 Mississippi, 2 Mississippi, then all of a sudden the thunder crashes. And that's because the speed of light is faster than the speed of sound. So I took my shot, and this is the audio from that shot, and I used a simple speed of sound calculation to validate the audio waveform that I'm looking at. So at the top, you see 2 lines here. One is left, one is right. And this is basically the loudness of the audio. And then down below, you see all these fancy colors. And this is really just a visual representation of the frequencies. The bottom being the low frequencies and the top being high frequencies in this clip. And this clip is 1 second long from the left to the right. So it takes 1 second to get from one side to the other. And that's basically what you're looking at. So the left and the right, you see these little things here are crickets, because I was out in the middle of a field, out in the middle of the country, on my property. And so it was very quiet other than the gunshot. So it came up really nice and clean. So we got a good thing to look at here. And on the left, where this begins, is where I took one of the cameras down by the target, about 15-20 feet away, was pointing back at my position. And I was doing that on purpose. I wanted to see my muzzle flash so that I could calculate the distance before I heard the sound. And I wanted to validate that the audio signature that I was looking at was consistent with the calculation for speed of sound travel time. And that's a very simple 5th grade math calculation. It's distance divided by speed. Okay, so if I've got a distance of 142 yards or 426 feet, my speed of sound is 1,125 feet per second. If you make that formula, and you end up with a 0.38 second travel distance. Okay, 0.4. If you look at the top, we're at 0.4. So this signature right here is the muzzle blast. This is the light from the muzzle blast, and this is when the blast hit the camera. Now, unique thing about a supersonic bullet, the bullet travels faster than the speed of sound. So the bullet will arrive before the blast, but it also, because it's supersonic, does this thing called a sonic crack. Okay, and you've heard of like jets going by, and they're, as soon as they break the sound barrier, you hear a big boom. That's what this little crack is. Okay, so this is the sonic crack, and then this is the boom, the sound of the rifle finally making it to the camera. Okay, very simple, basic math. Doesn't get any easier than this. We validated where it is, where the boom is. This must be the crack, and I'll give you an example of what that sounds like. Here's my control audio. 2 audio events happening. Crack and a thump. Pretty easy so far, right? I'm hoping you're following. So I'm determining that this is my muzzle blast audio signature. I know this is a 30-06. I know the distance. It's all known, inarguable stuff here. I'm going to roll down next to the Kirk audio from a similar camera position that I had set up mine at. And I kept the timeline, lined that all up so that you can see the same perspective. And what do you see here? What do you see here? It lines up. This is a 1-second timeline. Same thing. Same thing. You see the muzzle blast audio signature here. You see the sonic crack here. Okay. This green line is the first sign of impact. So in this video, to the back right of Charlie Kirk, it's the one where you kind of see him from the back right. This green line indicates the location in the video where I saw him react to being impacted by this bullet, by this gun. And there's a little bit of a delay there, and that delay is 100 milliseconds, but it's basically, it takes a minute, or it takes seconds for that sonic crack to reach the camera. So likely he got hit here, and then finally the crack reached the camera. It's called a Mach cone, M-A-C-H cone. You can Google that and understand that. It's kind of a thing. And so anyway, I got a muzzle blast and I got a sonic crack in the same position as my control sample. Okay. So that calculation, the next calculation is crack-to-thump delay. Now, with crack-to-thump delay, kind of a military thing, kind of some more deep sciencey stuff, where it says if you can measure the distance between the crack and the thump, you can get the distance from which the sniper is shooting at you from. That's kind of the science behind this. And that crack-to-thump delay, here I'm measuring at 0.2 seconds. So I said, okay, let's validate that with 30-06. So I used 2,800 feet per second for a 30-06, which is pretty common. It could be less, could be more. I mean, you can have different kind of rounds. You can have hotter rounds. You can have not so hot rounds. But generally, I use 2,800 feet per second, and I got a calculation of 0.228 as what we would expect to see in a crack-to-thump delay of a 30-06 at 142 yards. Okay, 426 feet. So that checks out. That checks out. Now, one thing you might be looking at here is how clean this audio is compared to this audio. And of course, we are in an amphitheater. It's much different. There's a lot of crowd noise. There's a lot of stuff going on. And this really kind of looks messy. And originally I was focusing in on these anomalies and trying to understand what those could be. Of course, again, it gets very sciencey and techy, and you really got to know more about audio to dig into this stuff. But there's a few things here that I saw, and I was like, oh, that's kind of messy. It's kind of weird. But then I went and pulled the iPhone that I took the same exact event. I had an iPhone and a camera, but iPhone is facing the target, camera is facing me. And you can see the crickets, little cricket noises, so you know this is the same audio. But this is messy. This has some of those same higher frequency, messy little spikes that you see here. So I'm not sure, somebody with more expertise in iPhone audio could tell me maybe, but this camera was an iPhone, and I think this camera was also an iPhone, and it's consistent with the messiness of what you see there. So that's wild. Anyway, that really kind of shows another couple things here. You see this little dark line, and then you see another thing here. This, I think, is after some research, is a ground reflection of the crack. It's kind of like over here. You've got another kind of look like another reflection looking thing. This is a ground reflection of the thump as it comes in. So there's a lot of bouncing and echoing that happens, and you kind of see a similar thing here with this line. It's kind of muddy, but it's there. Even here, you see that, and you see other little reflections and echoes and whatever. But that's basically the audio, and it lines up all the way down. Whether it's an iPhone, whether it's a 70D microphone, or whether it's whatever this was recorded on the day Charlie Kirk was killed. So that's the basic stuff of the analysis. And what that tells us, if this is true, if this 0.2 second delay is true, this shows a supersonic round. So then you have to ask yourself, okay, it fits the narrative, the official narrative that nobody wants to believe in, because everybody wants there to be something bigger. Nobody trusts the government. Nobody trusts the FBI, me included. But if this is 0.2 seconds, there's only so many guns that could do that, and only so much distance away. So the idea here would be to get the fastest gun that you could find, and then determine what the delay would be and how far that fastest supersonic gun would have to be away in order for this 0.2 second delay to happen to begin with. And this is where it gets a little more compelling. So I pulled up Google Earth, and I did some calculations on some other high-speed rounds, and we determined basically that you'd have to be 105 yards or farther, 100 yards at the, I mean, really, if somebody made a really fast round in a smaller caliber, something like that, 100 yards is really the number. You couldn't be within 100 yards of Charlie Kirk with any supersonic weapon with a 0.2 second crack-to-thump delay. This is the impossibility zone. This is where Tyler Robinson supposedly took his shot from. This is where Charlie Kirk sat. And this red zone means it's not possible. Okay, it's not possible to shoot a supersonic weapon anywhere in this zone. It goes around to the back. Of course, that doesn't, they wouldn't have shot from behind. So this is the impossibility zone. You couldn't have a shooter anywhere in here. Let that sink in for a minute. You couldn't have a shooter anywhere in here based on this basic, simple audio analysis. Sniper over here, not possible. Sniper over here, not possible. Take a look at Paramount Tactical's 3D model. I have it here, but I didn't pull it up. But you can't even see Charlie Kirk. This is down in a basin. It's down below. You get over here and you can't even see down in there where Charlie Kirk was. So, but you'd have to be outside this red realm in order for this to work, and you'd have to have a really super fast gun to get that crack-to-thump delay. And that's what's been driving me nuts about this whole thing. I know it's unpopular probably, but it is what it is. I mean, I can't unsee what I've seen. There's a lot of things about the official narrative that drive me crazy. The texting, everything seems too perfect. All that stuff, the confessions seems too like, who would you do that? Would you confess everything in a text message? And then, I mean, all of it seems sketchy at best. Should a 30-06 have penetrated and gone straight through Charlie? Should there be an exit wound? I mean, common sense tells you most likely there should have been, but it's possible that there wasn't. And if it was a 1 in a million chance, this is a 1 in a million event, and that was a 1 in a million thing that happened. I mean, I've shot deer where the bullet did not exit the body. It's happened. Skin does weird stuff. Now, skin alone probably isn't going to stop a bullet. I mean, it probably got deflected or hit a bone and then kind of got deflected into the skin. And I can see skin being very elastic and doing that, but you would have had to expel a lot of the energy out of that bullet some other way other than just angle of entry. Again, that's outside the realm of anything that I'm willing to do. I'm not gonna get a ballistic dummy. First of all, on a dummy or a ballistic gel or anything like that, you would have to be able to replicate the human skin factor in order to see if that would work. I've seen people spend a lot of money and waste a lot of good pork out there shooting up meat just to prove what we all know with meat and those things that, that's just not gonna stop a 30-06 round. But a living human body with living human skin and tissue, it's plausible, and this makes it more plausible because what else could it have been then? Give me this electrocution theory. This one's making its round, and it's absolutely bonkers. I mean, could he have gotten electrocuted by a mic? Yeah, they'd had to rig up a much higher voltage because it's not, mics are DC. And you'd have to plug it into the outlet. I mean, it wouldn't have happened that quickly. 120 wouldn't have killed him that quickly. And then, what of everything else? The shirt, the necklace breaking, the shirt puffing, the bullet wound, the blood blowing out of his neck. I mean, none of that conforms to the electrocution theory, which is why I think it's so crazy. But, anyway, take it for what you will. This is what I did. This is and this is what I discovered. And if there's anybody out there that can dispute my finding, dispute anything I've said here, please let me know, because it's driving me crazy otherwise. Anyway, thanks for watching. Do all the things that you could do if you'd like to. I'm going to try to keep making more content here, but thank you very much for watching. Peace out.